This video starts the series for systems of equations. So this video is going to talk about systems of equations solved using substitution. Before we get to the substitution aspect of it, we are going to understand what systems of equations are, how you get the answer, what they look like, stuff like that, and then we'll get into some problems. So systems of equations. What a systems of equation are is it's two or more equations that are solved simultaneously. And simultaneously means that it's the same answer for both equations, or three equations, or four equations, or whatever it is. So whatever the answer we get, it solves both of them. Okay, and what do I mean by solving? Well, when we solve the systems of equations, really what it is the answer is an ordered pair where the equations touch. So if I have an equation, doesn't matter what it is, and then I have another equation, wherever they touch is going to be the value of the answer. So it's going to be the answer for both, because that's where it solves them. That's where they're solved simultaneously. Knowing all of that information, let's get into our first example and how do we solve it with substitution. Substitution is what it sounds. Substitution. What are we going to substitute? If we look at this first equation, we see that y is equal to all of that. If we look at the second equation, we see y is equal to all of that. Because y in both equations are the same value, we don't know what the actual value is, we just know they're the same because they're both y's. And they're both one of them. Remember, we have a 1 in front. Because they're both one y, that means that I can take either of the right-hand side expressions and put it into the opposite y. So for instance, if I know that negative 4x plus 5 here is equal to y here, that means it's also going to be equal to y up there. So I'm going to substitute it in. Negative 4x plus 5 equals 3x minus 2. Because of that, now I can solve for x. You notice I took away a y, I added x's in, because those x's are equal to that one y. Now I'm going to solve this equation by adding 4x, by adding 2. So I get 7 is equal to 7x, x equals 1. So this is my x value in the ordered pair. Remember, an ordered pair is x comma y. So if I know that's my x, that means my answer is 1 comma something. I don't know what that something is yet. But if I know the value of x is 1, I can substitute that back into either of those equations. I can use the top or the bottom. It doesn't matter. I'm going to use the top. So if I know y is equal to 3x minus 2, but I know that x is actually 1, I can multiply and subtract to get y to also be 1. So since y is 1, my answer is 1 comma 1. That is the point at which those two lines, this one and this one, touch each other on the coordinate plane. If we were to graph them, that's what they would mean graphically. Okay, that's what it means. It's where those two lines touch. Let's work on this example here. This is the last example in this video by substitution. If I look at this top equation, I don't have y equals. I have what looks to be in standard form. This one here is in slope-intercept form, so that's good. I always want to start with the equation that y is equal to, because I know that this all equals y. So since 5x plus 9 is equal to y, I can take the top equation, take out the y, and put in what was equal to it. The bottom equation told me that this y is equal to 5x plus 9. So I'm taking it out, putting 5x plus 9 in. I'm going to have to distribute, combine like terms, and solve my equation. So here we go. 4x minus 40x minus 72 equals 0. Negative 36x equals 72. X equals negative 2. Again, you see I skipped a lot of steps. So if we know x is negative 2, That means in my equation, negative 2 is going to be in the x spot. Since I have negative 2 now, I can plug it into either this x or this x. Either or doesn't matter, but if I'm going to plug it into the top one, then I'm going to have to do a lot more manipulation. If I plug it into the bottom one, I don't have to do much manipulation at all. Negative 10 plus 9 is negative 1. So y equals this, which equaled that when I plugged it in, negative 2, multiplied, combined like terms, negative 1. That is the point at which these two equations touch each other on the coordinate plane. Therefore, that is the answer to this system. This concludes the video for solving a systems of equations by substitution. If you need help with elimination or with 3 variable systems, please watch the subsequent videos.